Formula harmonics.
Orange.
Just basic formula.
Good morning, Lavendan.
Hello, sir. Good morning. How are you?
How are you?
I'm good, sir. How are you?
Okay. We are happy to have you here. So
Thank you. Yeah.
We will start formally. Huh?
Sure. Yes.
Okay. So, good morning to one and all present here. First and foremost, I welcome Mr. R. Ilavendan. He is a hero of 2014 passed out student. Active participation in all the student activities in the department leads to the career to the next level. If we ask the 11th to take the art programming a month before, he is in India. Now you are in abroad, I think so. Is it so, 11th?
Yes, I'm in France, sir. No, currently I'm in France. Yes,
you are in France.
Currently I'm in France. Yeah.
Okay. So see that how the career leads to the next level. So this shows the active participation not only in the student level to the next level, that is employment level, and also in the family level. So we are happy to have such an improvement in the 11th and career. We are happy to see all those things. So next to that, coordinator Mr. A.LOGESWARAN sir, who organized this program. See that we find 11th is only the only resource person to handle all those things, while we search for any other aspect in the industrial level or in the academic level, means whether the economic will not shoot to our level, or otherwise the expectation is more from the industrial person. They are unable to take from the basics. So I should thank the alumni Kogilavani for sending the message, and also I should thank the A.LOGESWARAN sir for organizing this art programming through our alumni, Mr. R. Ilavendan. And I should thank Mainavati madam who organized this function in the formal way, and who suggested the following courses to be added in the value-added course. And I welcome my dear students for this value-added course, art programming. So generally what we shall say is, so art programming is a one, we may not say that art programming is a only concept, but we are having 70 to 170 students here. My outcome should be how it is some students, 5 to 10 students, will be get an idea about the art programming, and they will involve themselves into the deepest level. So how the 5 fingers in our hand is in different way. Like that, some students will like art programming, some students will be going into the web development, and some students will be in the hardware line, and some students will be in the networking, and some students will be Pega or other Python, various level. So our department motto is to show all the levels and all the technologies and all the programming levels to the students, and if they are interested, we may make it to the next level is our motto. And I hope that this session will be a not only a value added course, and the session should be the value that should be added to the student also. So I welcome once again Ilavendan, and I conclude my speech, and I leave the session to our guest. Thank you.
Thank you, sir. Thank you for your wonderful speech. So I want to thank again, like all of you. So starting from Manavala Sundaram sir to Mainavati ma'am and Lokeshwaran sir and then Kokilavani ma'am, because I was in a busy schedule. Like I didn't know that there is an event going on. So if there is an event going on earlier, like I would have been in person, maybe in August or in September. But anyways, so I'm happy to share my knowledge and share my findings with my juniors who is already presenting here. And as you said, Mainavati ma'am is the one like who taught me, you know, how to think out of the box, and how to be, it's not like always like you study in the course and then do certain things, pass the exam and then go. It's like think out of the box and think on your own to get the things done. So I believe it is the same again with the students now, and that is the reason we are organizing this course. And without further thing, like we can jump into the session, I guess. So let me start presenting my screen. So I think you should be seeing my screen now. Just give me a minute.
வெளில போயிட்டாரா வெளில போயிட்டா தெரியுமா
Sorry for the interruption, because I have to quit my browser and then reopen to share the entire browser. So I hope you are seeing my screen now. Yes, I am seeing it. Okay. To start with, let's not directly jump into the R programming. Before that, we'll give an introduction about what is R, what is R Studio, and what are we going to see in this particular session. Okay, so let me open a separate notepad. Okay, so there are two different things initially. So one is your IDE. I hope most of you would have known by now. So one is IDE and another one is the R environment itself. So why I am saying this particular differentiation is, whatever the UI that you are seeing, this is the R Studio. The downloading part, the configuration part and all, like we'll look onto it later. But initially there is a difference between the R programming itself and the R IDE. So why there is this differences in a secured environment such as PayPal, where I am currently working now. So you will not be allowed to have any IDEs. So for learning purposes, like we can learn it in an IDE, but when it comes to a particular professional environment, you will not be allowed to use any IDEs, say RStudio or Eclipse or Android Studio. So these are some of different IDEs that you have. But whenever you start programming on your own, I suggest you to work on the direct programming environment itself, which is just the black screen and this particular console. So that is a difference between the R and its IDE. So this is the R Studio that I'm currently opening now. Maybe it's a Mac environment, so the environment is kind of menu is the same, but when you download it on your Windows machine or on your I don't know, different machines, so it will be the same. The environment will look like the same in the same view. However, there are some differences here and there, like quitting options and the other options are there. I'll show you like where to download this one. This is not a big deal again, so if you want, like, you can download it from wherever you want. So again, this is the R environment that I was talking about. So the latest R environment is R 4.2.1. Okay, so in order to keep track of things, I'm writing everything in a notepad, so that at the end of the session I will share the notepad along with some other documents to learn, so that we can initiate the learning. So R 4.2.1 is you can download it from this particular website. Similarly, once you download this, it will be available to you as a simple package. But to use it for your programming purposes or for any other statistical purposes, you need a IDE. Like at your initial stages of your learning, you definitely need an IDE. So for that, you need a different so this is again RStudio Desktop is the one that you will be wanting to download. So again, so this R is different and this RStudio is different. What I would suggest you to do is first download the R first, and then you download the RStudio, so that you don't run into any issues when you're trying to initiate or create an R environment. I hope everything is clear for you guys. So if there is anything that you want me to stop on, like, you can just raise your hand or interrupt me if you're okay with the mic. So so now that environment part is set up, so I'll walk you through the RStudio environment. So the installation part and all, like, you can figure it out by yourself, like how to do, where to install, etc., etc. So I don't want to go deep into that and then make you install in your environment. So there are 4 unique parts to your RStudio environment. So when you download and install, there are 4 unique divisions in your RStudio. So the first one is this particular coding sheets. So whatever you save it in here, say RStudio, like .r files or the initial coding files, will be present in this particular window. And below that, what you will have is console and terminal. So console is where you I don't know, like where you can print the variables or see the results or write the code directly, etc., etc. So console is similar to whatever you'll be doing it in your C Sharp or C++ environment. I'm not so sure of your subject, so I'm just going ahead with an example. Anyways, so console is like you can write into the codes and then see the outputs, etc., etc. again. So once we create a variable of any sort, say I'm creating a variable A or variable B or variable C, so it will not be shown in here, meaning the variable creation, it is executed in the console, but the same variables are available in your global environment. So if you see here, A is assigned to 10, B is assigned to 10, and then C is assigned to 20. So why this is required is sometimes you want to see in a lengthy list of say 2000 lines of code or 3000 lines of code, like you cannot go into the code and search for a variable. So that is the reason the environment, the global environment or whatever the package set is present in here. So what you can do is, so this is a simple case of A, B and C. But if you have so many variables and so many lines of code, you can search in here like for whatever the variable that you wish, and then you can view that particular variable uh, to be present in here. So that is the third screen or third division. And the final division is the external environments, meaning, so R is not only for statistics and data science, like you can do the exploratory data analysis and you can view the plots or browse the files that you want, or you can even save the files. So the files will be present in whatever these things, and the plots and packages, etc., etc. Okay, so before we start with the initial or uh, initial programming, what we can learn is a simple trick that will help you to navigate in the R environment wherever it is required. So in the console, you just go and type like question mark and then help. The help the help topic from the inbuilt packages will be opened in here. So if you scroll in here, whatever the help that you require or whatever the package, or let's say I'm searching for a DPLYR package. So uh, since this package is not installed, it is not present in here. However, if you want another manual, it is kind of a manual that you can refer to. So even if you do not know like syntax of anything, let's assume group is something similar to the SQL group by, and if you put a question mark in front of any particular keyword, it will be present to you in this particular help document. So you can scroll through it. So you can see the syntaxes, you can see the executions, or if you see here, the entire code, the sample code will be present in here. So this is one of the handy tricks that we use. Like if you're very unsure of any syntax of any or command, you can just put in a question mark and type in your whatever the query, and then so that it is present in your help window. So I'll include that as well in your notes. So step one is know the environment. So now that you are aware of what is R, what is R Studio, and how to navigate through the basic R Studio. So this is the primary one. And here some of the handy tricks are like uh, use the question mark and know the controls. So why I say know the controls is there are so many menus and etc in here. However, if you want to do some basic printing, and if you just press Control and Enter, it will just do the addition and it will execute that particular line and then give you the result. So I'll not go into deeper of what is the control or how to execute each and every line, etc, because it will be available to you once you start executing on your own. So now the controls is there. Now we'll go into the packages and their installations. So quickly let me check for any questions or hands raised. I don't see anything. So yeah, so if you want, you can use this particular hand raised button to raise your hands and then ask any clarification or doubt. So uh, or if you want to ask directly, you can turn on your mic and then ask. So that is there. Okay. Again, so now that we are introduced to the R environment, there is some specific concepts called the packages installation. For example, for everything, there is a package installed pre-built. Um, the packages are similar to the libraries that you use in other programming languages. So in Java, like you have headers, and in C you have like hash include stdio and con io.h. So the packages are similar to that. However, these packages are not installed by default in your environment. So how to install the packages is something like you should be careful about. So this is how you install a particular package. So DPLYR is a computation package that will be used to group by and compute some minimum, maximum, etc., etc. So what you want to know is this particular command. So install that packages of whatever the packages that you want and the dependencies. So dependencies are something like to install this particular package, you need A, B, and C. Because without those packages, you cannot install the particular main package. So that is the reason when you install, you always give dependencies is equal to true. So if you do not give this dependencies equal to true, there will be some issues in some packages and they may not work the way they intended to do. So that is the reason I always use dependencies is equal to true. So if we give that particular command, so it will automatically fetch the package and then it will install the package in your environment. So I'll include this as well in your notes, because this is like a reading A, B, C of R. So without the packages, we cannot do computations or we cannot do anything. So that is the reason it is required, and you should be careful about it, because sometimes what we do is there are dependency errors based on your environment. Say your Java is not proper, your environment variable is not set properly, or even your environment is not set properly. So in those cases, we have to use this dependencies so that our environment is properly set up. And there are list of packages. So this CRAN R project is again the R. However, whatever the package that you want to download offline, without the internet connection directly. So you should always check for this particular CRAN R project in DPLYR. So if I just click in here, all the versioning details, all the dependencies. When I say dependencies, it is the imports. So it will import another package so that this particular command and execution works perfectly. So if you want to download it offline, say you do not have an internet connection sometimes and you want to do some things like, then you can do this offline download, and then you can ignore all these things. Like the only thing you should be concentrating is there is a PDF in here. This is the source code which is already present in the PDF. Already present in the package. This is the PDF I was talking about. So when you install a package, say any package, it is required by the open source community to document everything and provide a command for like whatever that you start to use. So whenever you don't know the package or you want to do something, you can search for the package in CRAN repository and then go for this particular URL, and whatever the filter or whatever the mechanism that you want to try on, it will always be present in this documentation. Again, and the documentation is very necessary for this art, because sometimes you forget the things, or you don't know like how this particular command works. So that is the reason you should always refer to the documentation when you are in Windows. So I'm adding the sample dpl layer package. So this is the sample documentation. Okay. So here is the URL. So here is the URL. So if you visit this URL and replace this dplware with any other package name, say, so instead of dplware, if you say forecast is another package. The forecast packages will be this is the package that I'll be using the most, and again it is the same structure, and you can use it for a different package. So once you start learning everything, like once you start your hands-on in this art, you will get to know like how to define a package, or how to even create your own package, etc., etc. So that is there. And then so I'm just opening the PDF version. Yeah. So what I will do is, at the end of the session, I will share you this particular PDF along with the notes. So my suggestion is to, if you go through this entire PDF, it is more than enough to know the basics of R. So when I say basics of the R, so let me start going through the PDF step by step. So the R overview, the R environment setup, the R basic syntax and all, like this is what we have seen in the past, like say 15 or 20 minutes or so. However, this R data types is the basic manipulations. So R data types, variables, and then operators, decision making, loops, functions, strings, vectors, lists, matrices, etc., etc. So it goes on and on till the end of like this or JSON file. Like that is where you you stop your basic exploratory analysis. So it is more or less like you can do the mathematics, Fibonacci series, and then all those simple mathematical programs you can start doing here, like until this file manipulation stuff. That is where your intermediary level of R starts. So intermediary level as in you connect to a particular database, and then you fetch the data, process it in here, and put the data back into the database. So that is the intermediary level. So the web data or databases or pie charts and Gantt charts and bar and box plots. So this is the intermediary level of data analysis. So when you delve deeper into that, that is where the real data science comes in. So the linear regression, the multiple regression, logistic, etc., etc. And this is how like your data science passion should evolve, in my opinion, honestly, because initially you are new to this R environment. So you are introduced to the basics of R, say your basic programming skills or basic execution skills. You will start by the chapters from 1 to 13, and after that you'll do the analysis. Say you are given a business problem, so you will handle it with different executions. So you can do the same in or in Python or in Java, etc. But however, when it comes to the data scientist, or as in general any statisticians or scientists, so they will use these particular ones. So the time series analysis, and then the least these are technical terms that will be very new to you. However, like I'll share, as I said, I'll share this PDF. So for this particular session, we'll concentrate only on the beginner level, the chapters 1 to 13, wherein you see the data manipulation and other things, not more than that. Okay. So any of you have any questions or any concerns? Okay, cool. So let us start going into the R environment, and we'll execute some commands. So yeah, this is how you uh, start an R environment in a command prompt or the generic R environment. So when I say generic, we will not be allowed to use the we will not be allowed to use the IDE in some restricted environments. So that is when you should use or in this particular command prompt or a terminal or a restricted Ubuntu environment. You can do whatever you want. Like this is a typical programming environment, so that the third party softwares are not installed in your work environment. So that is the idea. And this is we have seen, and our command prompt or script file is we have seen, and execution is right now you do not want to concentrate on the execution of the whole R file. We'll go this step by step. Exactly. So here is the list of data types. So far we have seen the introduction of everything. So I'll include the step 3 in here, the data types. So when I say the data types, it is not like your typical integer or string or character in the other programming languages. In R, it is mostly the vectors and the list. So vectors and lists are the individual ones as in when I say the variable A in here, it is not like the variable A is only the numeric variable. If I want to see the structure of A, it will say the numeric variable as 10. However, this A is technically called the vector inside the OR environment. So it is again the similar one, but for the programming and segmentation purposes, they have made it like this. For example, now if I'm executing a simple string array, and if I'm executing this particular line, line number 5, and if I'm doing the same structure, it is like the character array. So everything is segregated into the list of vectors, lists, matrices, etc., etc. So we'll start with the vectors, and then we'll go deeper into this. So to start with, there is a logical data type as well. So logical is something similar, and we can correlate to any other programming languages. So we'll say true or false, and it is again there is nothing to be fancy about. This is only special to the R environment. So there are certain things that is restricted only to R. However, these are like the basic ones. So the logical data type is true or false, and the numeric data type is it can be a float, or it can be an integer, or it can be a negative number, or it can be the root number, anything it can be. And the next one is the complex number, which you will not be using at all, because this will be used only in the research purposes. The characters and the raw data types, like raw data type as in this is just your memory. So it is something to say like it will be referred, or it will be stored in your system only through the memory, not as an actual data. So that is the raw data types. So these basic ones are called or grouped together to called as a vector. So when someone says initiate a vector or this is the vector of A, you just don't be scared about the terminologies, but it is the same that you use in every other programming languages. So the vectors are something the very basic ones, and this is where the real fun starts. So the list. So you can create a list by combining anything. So normally you will not be able to combine the data types together. So you cannot combine the 193 and then test. So these are different data types. However, when you put it into a particular list, you can do the manipulation on this particular list. So why the combining or the congregation of things is important is, usually when you get the data, it will not be in the proper format of Excel. So that is the reason the list concept came in, and it is like grouping of the similar or dissimilar data types. So say if you want to do an example of words, then you can do as well. So all you can do is you put everything into the C parenthesis, the combined parenthesis. You open it and you can keep on adding the list elements to the list, and then assign it to a variable. So assign it to the variable of X. So if I print X, now we have like 3 variables: sky, test, and think. Accessing is something very similar to the other programming languages. So if you say X of 1, that is how you access a particular variable, and it's not like the typical C# array or C++ array where the array starts with 0. It starts with 1 in here, like the list accessing, it starts with 1. And when you say the list, you can also test the length of the list by the length command. So these are all pretty basic stuff, I know. So for some of you this may be new, for some of you this may look like very rudimentary, but that is the very idea of the R. Like you don't have to stress out too much. Like you can do in the descriptive terms, and then you can create so let's assume you want to create a package, and you can do the same thing as well. So that's the beauty of the R language. So we'll go to the matrices. So matrices is something like you'll be getting in your programming tests, I guess. So it is the same. And again, for everything, the commands are descriptive. Say you are not sure of the matrix, and you don't know the syntax of matrix. What you can do is you can type in here, and you can just put a question mark in here. I hope it is visible to you all. So if you put a help command over this particular matrix, whatever you wish to look for, it is present in your usage stats. Like here is how the syntax of matrix should be. So let us explore the particular syntax before executing a command. Okay. So the syntax is the same, and the data is present in the form of a list. Okay. So data is equal to NA is what the syntax is provided. But however, we have a list in here, and n row and n column mentions the number of rows and number of columns you want to create in a matrix. So usually how you will create in a matrix is like you will write a simple for loop or a while loop, and then you keep on adding the elements to the matrix. So ideally you should mention the number of rows and the number of columns. So by row as in how do you want to fill the rows? Like it will be more explanatory to you once we start executing this command. So right now I am executing the command, and if I start seeing this M, it will be by row as in the elements are filled in the row format. See this A and B, it is present in your first row, and then C, B, A, it is present in your second row. Let's assume we are okay. I'll create another variable which is M1. So if you want to create this particular M1, it is almost like you'll be filling in terms of like column. So if we see this M1, it will be in the column filling order. See, for example, A, B, C, and then B, A. So normally when I was studying, like the matrix reversal is, I think, a different program altogether in terms of like the traditional programming languages, the old school programming languages, say C or C++ or the other languages. However, if you want to create a matrix and then if you want to reverse it, like you can just tweak the by row parameter, and then you can achieve this particular the objective from your standpoint. So again, this may look simple, but when it comes to your work profile, or if your project, let's assume you want to do certain projects, then it might come handy, because the number of lines of code, it is vastly reduced when you use or R related packages. So that's the idea. So now we have matrix and then arrays. So this is the typical array. Array is somewhat similar to the matrix, so I don't think so like we have to go into this arrays. So because we have a lot to cover, so I'm taking say 1 or 2 minutes for each of the items. So I will try to cover as much as possible. In meanwhile, let us see. Yeah. Again, factor. So this factor is something which is similar to manipulating your variable. Okay, so let's assume you are creating a vector. So let's assume you have this particular array or whatever the list that you have. So this particular list is there. However, if you want to do an operation, say how many levels are there or how many groupings are there, then it is better to convert your vectors into your factors. Meaning, so for same vector, you will be creating a factor so that your manipulations are easy. So when I say with an example, it will be clear for you. So I'm just copy pasting because I don't want to just type everything out and then do certain things. So I'm executing some things. Yep. So this is where like the factor comes into the picture. So this apple colors is your plain vector. Plain vector as in this is your vector which is of the list type. So to give you some idea, so this is your character list which have like 7 elements. However, when you want to count each one of them, you have to count like green 1, 2, 3 and then so on and so forth. But to avoid all those hassles, what you can do is you can create a layer on top of your vector. So that is your factor object. So when you factor something, you are creating a manipulation layer on top of your vector so that your levels and your other descriptive stats is available to you. So the descriptive stats as in it defines your data. So there are these many levels, there are the lengths, and there are the levels, and there are these many characters or your descriptive stats. So when you start into any analytics or statistics course, the descriptive stats is something that is available to you. Meaning, before you jump into any analysis, you should first know what is the data is about and how the data looks like. So that is where this factor comes in. And once you print your factors, it will show you the levels of this particular character vector. So character list vector. So to confuse, I don't want to dump too much information. So let me clear everything. So what initially we'll be doing is we are creating a vector, but when you display the vector, it just displays the list as is without any manipulations. But here you are factoring in as in you are adding an additional layer on top of your whatever the variable or character list. So this is there, and once you print that factor, you will get to know the levels of the data. Say you have the sample the sample data set which is inbuilt in our environment is this empty cars data set. So it's a data set that we'll be seeing later on. But when you see this particular data, like you do not get any idea about how this each lines will look like. So to give you some introduction about this data, this is about the cars, like the vintage cars such as Mazda, Datsun, and Hornet, etc. However, it is about how much the car is performing in a F1 circuit or a race circuit. So MPG stands for miles per gallon, and CYL stands for like cylinders. Say initially the cars are categorized into the 4 cylinders or 6 cylinders data set. So to give you some context, if you have seen the Fast and Furious movies, I think the Vin Diesel will have like say I think 12 cylinders and turbo engine, I guess, not sure. But again, to relate to the data set, I'm giving you a real world example. And disk is your displacement, and HP is your horsepower, and DRAT is like your drag rate, and then the weight, and then the other parameters are there. Like, however, we might be concentrating on the miles per gallon, the cylinders, and the displacement rate. So that is on the later part, like if we have time. So why I am explaining you the data set is, when we see this particular miles per gallon, it is not like you do not have the entire length or the range of this particular variable. So even here I have just displayed the head of empty cars. So if we want to view the entire empty cars data set, so this is the entire data set, like your 32 entries are there. So in here it is not humanly possible. It is possible, but it will take time to count each one of the variable and see their range as in. So miles per gallon is something very important. So it is like your mileage of your car. So it is very important. However, you do not have the data of the range of the cars. So that is the reason you have this factor. So if you factor in say empty cars of whatever the variable, then you can see that there are 25 levels. Again, this is the difference that you should note. So there are 32 cars in your data set, but they can be grouped into 25 different levels, which is 25 unique values are present in your dataset. So this is quite important because these are unique cars. So if you see for an example in the header, there are two cars with the same mileage. So this makes a differentiation when you are doing certain analysis on your car. So this is again a sample data set where in a real world data set, it will be even more complicated. For example, the cylinders is something that can be grouped into three different groups. So if you want to filter out the only four cylinder car or six cylinder car or eight cylinder car, uh, it is like if you want to do it manually, then you should count each and every variable. So that is where you have to convert your vectors, say character or list or any other data vectors into your factors so that you can view them clearly like this. So is the importance of factors enough, or do you guys have any other question? I'm checking for questions in chat. No questions, no doubts. Everything is clear for you guys, or do you want me to explain anything more, or do you want to do anything other than this? I'll wait for a minute. Cool. So if at the end of the session, I'll give you my contact list. Like if you want to contact me, you can contact me. Anyways, we were talking about the importance of the factors and why is it important to convert your vectors into factors so that they can be grouped together and viewed together. So that is the importance of the factors. So before going into data frames, a simple introduction, because the data frames is an important concept in R. So everything that we have will be converted into a data frame and it will be converted into the usable purpose. So because these vectors and factors, these are like the simple variables that you will not be having it in your real world environment. So when you have the initial data, they'll be loaded and computed as a data frame. So I'll show you the data frame. So we'll take the cars data sets itself. So end row, end column, these are the commands that I'll be using often. So I think most of the commands will be self-explanatory, and if there is anything difficult, I'll be providing you an explanation. So for now, we are just seeing how many rows are there in the empty cars dataset. Okay, we are creating a test dataset with the head of empty cars. So when I say head, it will just display the initial 6 rows of a particular dataset. It is just to just for you to get a hang of the dataset. So I have created test data. So the command is executed, and the command is it is already present in your the environment. So if you see here, it is showing as the test data 6 observations of 11 variables, meaning what you have is 6 rows, the number of columns is the 11 columns. So now if I do the view command of test data, it will be only the first 6 cars. So if you see empty cars, it is like the whole data set. However, for the test data, it is only the first 6 rows of your data set. I hope this data frame is made clear to you, because these data frames, you can do n number of things with your data frame. For example, so the n column thing. So the only difference between the base or parent dataset and your test dataset is the number of rows. So again, we used to do computation in R with millions and millions of rows. Compared to them, this may look simple, but this is to give you an idea about the exploratory data analysis in R. So when someone gives you a data set and asks you to do some analysis, like you don't directly delve into it, you just start creating, you just view the data first before jumping into or any coding questions. So typically I was in a programmer mindset when I started my career. So what we'll do is we'll try to solve the problem first, and then we'll directly go into the programming. That should not be the case, and I would suggest you to take a look at data set, understand the variables, and then go for your coding if you are interested in the solving the business problem. So that's my suggestion. So we'll, I think, go to the variables part. So again, this variable declaration part is the standard one, wherein you should not start with a number or a special character, etc., etc. Like it's like the same set of standards that is universal to all other programming languages. In assignment, is we have seen it in the previous ones, like in the introductory sessions, like we have seen. So I think we can skip the part. So this data type is what we have seen in the string type, like a structure one. So now I have created AR underscore X variable. So what I can do is I can see the class, or I can see the structure. So when I see the structure, it will be shortened into 3 characters, say CHR or in numeric or integer. So when you see the class, it will just give you the class, or what is the data type of the particular variable. So if you want to check your the computations or check the authenticity of the data, then you can use this particular class. Or usually for easier purposes, like I use the structure command. So it is, both of them serve the same purpose, is what I'm trying to convey. Okay, so the deleting the variables and all, like it is not that important. Again, now we come to the operators. So this arithmetic, relational, logical, and assignment operators are almost the same to the other programming languages, but R gives you the leverage to use your own assignment operators. Meaning, so when I say A is equal to 10, the A will be created in here. B is equal to 10, it will create again. So yeah, I have already created a variable, so I'll create another one. So it is the simplicity of this particular programming language I'm trying to convey at multiple points in this session. So either you can use equal to, or you can use the traditional I don't know, this arrow operator to initiate or assign your variables. For example, in other programming languages there are strict conventions. If you take Python, there are strict space conventions and naming conventions and assignment conventions. Instead of equal to, if you use another equal to or another symbol, it will be throwing you an error. However, for R, like you can use multiple, you can use like your native language, like whatever we say, if we start to type in, it will start make sense to this language. So that is the idea of R. So plus, negative, and then these are multiple like the basic arithmetic operators. This is where you will be introduced to the new operator. Like usually the simple percentage is called modulus operation. So what you can do is, so this is the basic division operator, and to get the reminder of, like, say, the uh, reminder between your whatever the numerator and the denominator, like you can do this particular I mean, you can use this particular operator. So this 10 double percentage stands for the reminder that is provided, like, after the division. Again, so if you use the slash in between, the division symbol in between, like, you'll get a quotient, or I don't know, like the multiplier of the particular mathematical operation. So that is what is explained in here. So if we use the vectors, it will be, a little bit confusing or might be advanced for you. So that's the reason I try to use the simple mathematical operation in my environment. So if I say 10 modulo 3, then it will give the reminder of 1. So because 3 star 3 is 9, and you'll get a reminder. And instead of double percentage or modulo symbol, if you insert another operator, like, you'll be getting the portion of it. So those are the arithmetic operators. Now it is like your a cap operator or power, like so POW is a so these powers are and all like your typical scientific operations. So to use this POW, you should install a particular package which is not currently present in here. So whenever a particular package or function is not available to you, an error message will be shown like this: could not find the function POW. So since this POW is restricted to that particular package, it is showing this error. So what you should do is you should install another package, say math package, into this environment, and then use this POW. So if you do not have that particular leverage, you can simply use the cap operator, like 2 power 3 is your 8. So it is again a basic math, so we do not have to worry about it. These relational operators, I think it is pretty self-explanatory. The greater than, less than, greater than or equal to, less than or equal to, and all. So double equal to is it checks whether the list is similar or not. So that is what it is. And this greater than, less than, and not equal to symbol. So it's more or less pretty standard, again, as I said in my in the start of the session. So the logical operators. So you might have seen and or operations in multiple courses of your studies, say in signals and processing, and then in your microprocessor, etc. You have seen it. So the same thing when you convert it into a programming language. So whatever the conditions are applying there, it will be applying in here as well. So the ampersand symbol is AND operator, and the OR operator is like uh, the logical OR operator is a simple straight line, and then the exclamation operator is like a not operator, so which is preceding the not equal to. So it is again self-explanatory, so that I'm not explaining you with an example. So again, you can use a simple AND operator or a double AND operator. It's up to you to use which one to use what. So after that, we'll have the assignment operators. So these are the different assignment operators that you can use in OR. So again, we have a left assignment and right assignment and so on and so forth. However, like, you can use multiple things. Say if you are using the C++ now, and if you want to transition to OR environment, then in pretty much similar cases, like, you do not need to change any other any other part of your code in the assignment portion, because in C++ you'll use this particular operator somehow, and it will be simple for you to transition from the other environment to this environment. So that's the idea behind this assignment operators and the other operators in general. This is the right assignment. So either you can do like a variable name first and then the variable value next, or the other way around. It's up to you how do you want to use it. Yep. So this is the most interesting part, like the miscellaneous part. So let me show you with an example. So normally how do you initiate a list of 1 to 10 in any programming languages? So it will be like you will be starting from 1 2 3 4 5 6. Say in any say in C++ you are creating an array of A, then you'll write something like this: 1 3 4 5 6 sorry 6, etc., etc. So you'll be assigning something like this. But in R, if you want to create a sequence, it is pretty simple and straightforward as well. So now I'm trying to assign a variable um, of A, and the value starts from 1 to 10. So it is as simple as giving the colon. So if you look in here, I'll print the variable A. So you do not have to write the lengthy code or the expanded version of whatever the array that you wanted to do. So what you can do is A, and then give like the range, whatever the range that you want. So let's assume you want to create a range of 1 to 1000. You can simply write 1 to 1000 and it will be present in here. So for displaying purposes, I'm printing an A, though it's not a good habit, but it is just to show you how easy to create the variable list of like 1 to 1000. I'm pretty sure in other programming languages you have like a for loop, to write, or you have to source it from somewhere to do these things. But in R, again, it is simple and it is convenient for you. I am emphasizing on this point because it is for the ease of use to your research or study purposes. So that's the idea. So okay, now you have the variable A, which is assigned to the 1000. So you can do all sort of manipulations in here. So just if you want to make sure that the numbers are correct, like you can do these things. And the idea is you can start the variable from any point. It is not the sequence has to be from 1. You can create it from any midpoint or any terminal point as well. So say if you want to create a numbers list from 900 to 1000, it will be like 101 numbers. So it will be you can create in between as well. So it's not like it is restricted. It is flexible, and you can use whatever the variable name that you want. And yeah, it is a simple example that is provided here. So this is one of the important operators which creates a sequence for a given vector. So it is applicable only to the numerics. So variables, I don't think so it is possible. I mean, it will not make sense also to use a sequence for a character array. So it is available for numbers, numeric array too. So you can use this particular operator, and you can use the in operator. So this in operator is again something very, very important. So say for example, in this particular array, you want to search a number. So all you can, what you can do is you want to check whether this number 800 in A. It is as simple as you are talking to someone in a natural language, like a human language, and you are asking whether 800 is in A or not. So it will just provide you a false condition, like a false statement. So it's a logical operator in a sense. So you can write your if statements. If 800 in A, then print 800 is not present in the variable. So if it is present, yeah. Yeah. So if it is present, it will show you. I mean, again, this is a logical operator. So if it is true, it will say that it is present, or it will 800 is not present. It's a simple if-else statement. So the idea here is it gives you some sort of leverage and some sort of ease of programming in terms of like writing your own program. So for testing purposes, like we can check for like 900 and see whether it is present in here. So in here, like 900 is present in this particular variable. So yeah, so that is there. Later on, this is the least used operator, which is for like a matrix multiplication. Like you can just skip it. Like we'll not be using it unless until like there is some matrix operations involved. Now coming to the traditional part, let me check quickly the time. So, yeah, we have time till. Yeah, what we'll do is we'll take a short 15 minutes break, and then we'll regroup on say 11:05 or 11:05. So probably. Is it okay, ma'am, for you? I think so. I think so. It's okay. Like we can go for a short break and then we can come back. So we'll come back in a while so that it'll be easier for you to understand and test the things. Okay. We'll take a short break.
என்ன இவரு ஏற்கனவே 2 அசிஸ்டன்ட் வச்சிருந்தீங்க, நீ நை நை நச்சாத சரியா? இங்க வா இங்க வா. வாட்டர் பாட்டில் கீழே போய் குடி. கம்மியாக வேலை முடிச்சிருக்கோம்.
think the time is 11:05. We'll just wait for another minute to resume this session. So after that, like we'll go through some of the important topics. Like so far we have seen only the basics. So we'll just give a couple more minutes and then we'll start. Yeah, so I think we can start now. Like if someone is out or late, I mean they can join later on. So sure, Elamo. So I'll share the document after the once the session is over, if that is okay for you. So I'll definitely share the documents and the notes that we have prepared during the session. So yeah, again, so I'm going through the table of contents again to just give you like whatever we have covered so far and what are we going to see in next 1 or 1 hour 15 minutes or so. So far what we have seen is the org overview. We have seen like the environment setup, the basic syntax, the data types, the variables we have completed, like what are the variables, data types, and so on and so forth. The operators is where we have completed. The miscellaneous operators is where like we have last completed before the break. And the decision making and the loops are like I think so pretty self-explanatory. Again, there is nothing like it is done uniquely in R and it is not available in any other programming languages. No, it is not like that. So if else is same in R, it is same in Java, it is same in Python, it is same in every other programming language, all the conditions. So I think we can switch, we can skip that particular part. And the loops are also again the same thing, like the while loop and for loop and the repeat loops are like it will just the same for loop and do while loop. So you will be I think you will be bored if I go through you the same syntax again and again in R. So I think if you study on your own or if you explore on your own, that will be easier for you. Now we'll go to the important concept of functions. And I'll give you a summary of like what are we going to do after seeing this functions. Okay, so here like these conditionals and loops, like we can skip for now because that is self-explanatory. And functions are is what that we are going to see. And functions, strings, the vectors and lists we have seen already. How to create a vector and how to access the manipulation functions for vector, like we have seen. So those are there, like the lists and matrices. So this is these are all simple ones. So I want you guys to like get started on this data reshaping. So after seeing the functions, we'll be going through the data reshaping part because that is important one, and we'll be looking on like how to view or how to load a CSV file from the external environment to the to your internal environment. And then the CSV and Excel files are the same. So XML and JSON are like I think so somewhat advanced to you. So we'll skip those parts. After that, what we'll do is these databases, and we'll conclude with the pie charts. So that's my idea. Let's see like how far we can go in this. So this is to give you an overview about like how the next 1 hour is going to be. So where were we again? Yeah, we have to see the functions. Yes. So when we say functions, again, it is similar to like how we use it in the traditional programming languages, like write once and use it anywhere concept. The idea here is if you have a lot of functions, you can even publish your own package in the or repository. So the GitHub code that we have seen earlier, like we can do that. So what I'm trying to say is, if you're doing a activity again and again and again for so long, you can create a package for yourself and then you can publish it so that the other developers can also make use of that particular package. So that's the idea. But this particular header file concept is not available in the traditional programming languages, is what I would say. Like in Java or in C or C++, if you have to create a package, you have to be very careful because it will somehow mess up with your internal ecosystem of your environment or computer. So that is there. But in R, everything is done in your RAM. So that is why it is fast, first of all, and that is why it doesn't affect your other operations. So let us go to the function definition. So let me name the function as test func, and so I'm just doing a basic operation. So this is again a basic operation. So what I'm trying to do is I'm trying to create a function of A and B, and once I get the A and B, what I'm doing is I'm adding 10 and 20 respectively to A and B, and then I'm printing the result. So I'm not returning anything. So there is no return data type and all. Like, it is just to give you an idea that the function concepts exist in this programming language as well. So the usual stuff which you might be pretty familiar with. So 1 comma 3. So I'm passing the parameters as 1 comma 3. So A will be 1 and B will be 3. So it will be 11 in here. So after the computation, and B will be 23 in here. So added together, it prints the 34. So it is pretty simple and straightforward, like which you'll be finding it in any other programming language as well. And you can use obviously the return statements if you want to return the variable and then use it for your other processing as well. So that is not a problem at all, and it is a again a straightforward process. So the function name, arguments, function body, and return value, it is like a pretty simple textbook explanations. Like, we don't need to go in detail for that. However, there are certain built-in functions. So the like one that we used earlier, right? Like the sequence or the sum, mean, median, mode, average, etc., etc. So these are these are built-in functions, meaning so the developers already have written that for you, so that you don't have to write your own function. So, for example, here we are doing the same operation as that we did it in the other way. Uh, so we are printing it from 32 to 44. So this is one way of achieving it. Another way is the what we already have seen. 32 to 44 is, it is again the same. Meaning, so if your end objective is clear and concrete, there are multiple ways to obtain that end objective. So basically, I want to be as simple as possible. I prefer this particular line, which is 32:44 to this particular line, because there is less chances of making an error in your program. So this is how I prefer. It's up to you which one do you want to stick to for your purpose. So these are the built-in functions, and user-defined functions or user-defined functions is again, I think by now you might have seen this multiple times in multiple languages and scenarios. So starting from your first year, I believe. So calling a function and return types, etc., etc. So it is the same. So we don't need to do anything. The only difference would be like you can use these dots. So uh, particularly, there is no class concept in R, meaning so there is inheritance and there will be class, there will be object, there will be access restrictions in other languages. Meaning so in your curriculum, if I am not wrong, there is inheritance, polymorphism, those stuff. But since R is primarily used for the statistics and data science, there is no inheritance concept. So that's the reason if you want to group multiple functions, you use this particular notion. So new dot function. So say you are willing to group the functions by their order or by their working purposes. What you can do is you can create something like class one dot test function. So the class one is the literal class meaning so it serves the same purpose as a class. So let me give a different name. The idea here is to group the different functions into a simple function. So if I minimize these, so this is the helpful feature of RStudio. Like you can group these functions together so that they look similar. So now when you have like a lengthy list of codes, you can see that somehow these two functions are similar and you can group them or debug them together. So this is one of the the handy tricks that I used to tell. So it is not at all equivalent of the class and the access restrictions in C++ or other traditional languages. It is more or less like you group them together for different purposes, and you can call the functions within another function. Meaning, so inside this function, you can call this one so that your number of lines of code written is reduced. So that is there. So that's the reason I wanted to. So even though functions is pretty straightforward, I wanted to call you out because once you draw the parallels between the traditional programming languages in R, at one point in time you'll get to know that there is no class concept in R. So that is the reason I wanted to go to this part. So again, with the function, without a function, by position and by name, the default values, parameter passing and all, I think you might be already familiar. So we don't need to go in detail through that. These lazy evaluation and all, like if you do not give a particular default value, then it computes the if you do not pass a value as a parameter, it computes a default value. So I think this again is like it's like a working for you. So we don't have to see an example for that, I believe. Now the string manipulation. So similar, so when I say string manipulation, I remember my times in the computer lab in C or C++ programming, where you have to write a lengthy list of codes. Say, if you want to find out a particular string's position or particular uh, uh, whether the string comparison replace a particular string or a particular character with this particular character. So these and all used to take like it used to be a separate exercise for us, and I hope so there is some exercises for you now as well. So why I'm trying to tell this story is the string manipulation is very simple and clean in this particular R environment. So we'll go through the examples in detail because this is something I wanted to delve deeper into the concept. So we'll start by saying these things like we'll start with the strings like string action and you can skip that part. So this is like the list of values that you have for string. Like you should not have the mixed codes. So if you see, for example, not meaning. So I'm creating str1 string. You can either use double quotes or you can either use single quote. So there is no restriction to it. Like I know this might sound very new to you, but a single quote that is there, and welcome to the concatenation. So when I say concatenation, like how it used to do, assuming that you still use some of the programming languages, you use like multiple I don't know, for loops or any other. It is as simple as combining the two way. Way. Yep. If you see here, if you just give the paste command of paste of a example, yeah, again one more example, like one more trick in here. So when you start typing into it, typing a command, if you just wait for some to the trouble. So if you just type in paste of str1 command str2, it will just combine these two strings and give you the final string. So similarly, there are other string manipulations such as I mean, there is the numbers and formatting things. Just like how you do it in the Word, you can format your numbers to left align or right align or center and justify align. So this is something like you will not be requiring, I guess. So the formatting of a decimal point. Say if you want to, the limit the number of digits, you can do so in here, and so this one. So now we have seen the number of we have assumed hello variable to a t. Okay, so now when we count the number of characters in t, which is given by n char, it shows, it counts the blank spaces also. Like if you see in here, so let me view it for the better purpose. Like if you see in here, the value is just given as hello, but however if you look closely, there are blank spaces before and after the words. Like it is something similar in the string computation. Like it counts the blank spaces as well. So I want to highlight that one as well. So the two upper and two lower functions are like okay, let me show you this. x1 is equal to so this is some special string, so which is a mix of both upper and lower case characters. For example, like say if you are using your traditional programming languages, you will be assigning a value and then computing it by saying like okay, so the variable is here, I want to do an upper and lower case, so I'll add these many values to the encoding so that capital A is converted to small a. However, we have a built-in functions for that. So if we just say to upper of x1, it will convert everything into an uppercase characters. Similarly, the opposite is also true. If you want to convert everything into lowercase, then it will convert every characters into the lowercase. So this is again a simple built-in function, but it saves you a lot of time in terms of computation. So that is the idea behind this particular one. Um, okay, here you go. Like the substring function. Let me start. Okay, let me start by saying by assigning a variable x one equal to. So when I say substring, if you just give substring function, it is not like you start from particular substring. This is available somewhere in every programming language. But the thing is, it is the positions. Okay, the spelling mistake. If I say 5 to 7, so for yeah. So if I say 5 to 7, whatever is present between the fifth and seventh positions included, so that will be displayed to you. 5, 6, and 7 is displayed to you. So this is to uh, make the string manipulations more easier for you. So that is the idea. And where were we? Yep, string manipulation. So this is where we have seen substring. Yep. So these are the simple string functions and substring functions. Like with this, I think you can, uh, we can do multiple operations using the string manipulation. Meaning, so strings are something that we do not use often. So they are part of like the logistic regression and other predictive algorithms. We don't use those algorithms for here. Like for us, mainly the numbers are bread and butter. So we go with numbers and go there. So now we go to the part again, like index, and see where we are standing now. So the loops, the strings are completed. Vectors and lists or something that we have seen earlier as well. Matrices, arrays, etc., or like used for like the basic manipulations. Factors and data frames. Yes. So the packages or something. It will show you like how to create a package. So I'll send you the document and you can go through the document when you have time. So we'll skip that part. Now we come to uh, the data manipulation part. So this is what makes R programming as it is, like why it is popular among the data scientists and researchers, because when you do something, it is pretty simple. Like there are small elements, small inbuilt functions here and there. So that's the reason I showed you all those things. But this data manipulation, it is pretty unique to R and somehow in Python. So I'll show you how. So normally, your data will look something like this. So Tampa State, Seattle, Hartford, and Denver are different states in United States of America. So for those cities, we have states, Florida, and so on and so forth, and they have the zip code as well. So if the data is from multiple sources, you will be loading it in the different vectors like this. Okay. However, if you wanted to combine all these data, the current option for you to is like you cannot combine data sets of like multiple data types together. However, with R, you can use a simple C bind or R bind. So I'll add the topics, because step 3 is pretty simple, like data types, functions, etc. functions and other basic elements. So this is simple, like that's nothing compared to. So you can live with other programming languages as well. But data shaping and sizing is pretty important for you. So that's the reason, and that's the reason I'm including it as a next section instead of in the basic section. So coming back to the code, what we can do is we can combine these things together. So cbind is column bind. So what you are taking is I'll execute uh, I'll execute this city, states, and zip code. So if I if I see the zip code, it is like the whatever the data is present in here, it is there, and state and city as well. The cbind, what it does is cbind of city, comma state. It just combines your two different lists into a one single data frame or matrix or whatever you want to create. You can create it as simple as that. So cbind of city, comma state, comma zip code. So you do not have to do, I mean, uh, I'm again emphasizing on the simplicity of this particular language, because this for you to write this, it might require at least 3 nested for loops or any while loops to to achieve at this particular point the aggregation of these things. However, in R, it is a simple straightforward statement wherein you just type in A1 is equal to, so I'm reusing the same code again. So if you just give A1, the character array A1 will be created, and once that is created, you can convert the A1 into a data frame, data.frame of A1. So if you look A1, it will be like your proper table. So I will repeat the process once again, because I think I might have gone too fast. So what we are doing here is, initially we are having 3 different lists. So one is city, and another one is state, another one is zip code. Our objective is to create a table or combine your data into a single object. So when I say single object, be it a matrix or be it a list or be it your data frame, it can be anything. But our idea is to combine these things together, because we want the information to be related with each other. Because Tampa is in Florida state, and Seattle is in Washington state. I'm not sure of state code, but however, these relate to each other, and these cities have these codes. The only problem is the source of the data. So in here it is 3 simple straightforward statements, but in other things, like in other areas, like when you deal with the real world data, this is so important that you have the data grouped together. So to do that, in other languages also, you will be creating multiple for loops, and you will be doing sanity checks, etc. But however, in R, there is one statement, which is this cbind statement. Let me type it. Cbind of city, comma state, comma zip code. I will execute that one. So if I execute it, it will be like a character array, because if you see this character array, then it will be like it will be given with your codes and your commas and etc. To clean this and for simpler table use sort of thing, what we can do is we can convert this A1 which is character array to a data frame. So how you can do is, it is as simple as that. So data frame of A1. So, and I'm assigning back to the variable again. A1 is the data frame of A1. So once we do that, all these extra variables and the formatting options will go away, and you will have a proper table data frame. So this is the idea behind everyone using R. Because of the simplicity, we are using it. So I think the cbind is something unique to R. So that's the reason, I wanted to show you this particular example and the reshaping and resizing of the data. So we have multiple examples. So I think so in here they have created with so many variables like addresses, and then they had a header, etc., etc. So again, it produces the first data frame is this one, and the second data frame, like they have added some more data to it, and then they have combined the two data frames into a single data frame. So here, if you see, we'll do that one as well. So far, I think you should be clear about like how do we create a data frame. I'm creating another set of data frame, but this time with the different data. So this time we are creating different city, which is Lowry and Charlotte, which are in Colorado and Florida, I guess. So in these states, we are reusing the same code, and we'll be having the data frame as A2. So now if we look at A1, it will be with 4 cities. A2, it will be with 2 cities. The similarity between these two data frames is very similar, because we have city, state, and zip code, which is same and which is in the same format. So what we can do is we can combine these two data frames together with a row bind command. So in here we have created a column bind because we want to append one column to another. Like we want to create 3 columns: city, state, and zip code. So we did that particular appending. However, to combine these two data frames, say initially on first month you get some data, and on second month you get some other different data, but you want your data set to be updated, then you create a final A3 data set, which is a resultant data set of A1 and A2. So this might look pretty similar or pretty easy, but this is one of the reasons why R is very popular. So that is the reason I have directly included the code in here, because cbind and rbind are like your ABCs or your basics for your R programming language. So that's the reason I went a little deeper, I guess, into this particular topic. So once you get it, like you can again, so instead of so in here we have the column names, which is the similar one. Say if you do have different column names, then you can use this particular merge. So they have given the merge command. So it is similar to rbind. However, like it is somewhat advanced to you, I believe. So that's the reason I'm not going to show into a deeper level. So, but keep in mind that merge function is similar to rbind. The only thing is you can use by x and by y, meaning so x is a data set, y is another different data set, and you can combine the data frames by their values, and you can merge those two data frames. So that's the reason they have given the merge command. Casting. So this melting and casting is another important topic. So okay, before going in there, let me check whether do you have any questions. I don't see any questions or no hands raised. So we can we can start into the melting and casting part. So okay. So far we have seen the basic data sets, string manipulations, and then some of the unique features of or some of the not so unique features of or. But this melting and casting is like casting a particular variable into a different variable. So say if you want a number to be treated as a character, then you can do so. Similarly, melting is you combine multiple data frames together and you create a resultant data frame which is completely different from your first two data frames. Suppose if you want to create a state code, then you can do the melting and casting, and you can combine ASL hyphen that particular zip code to create the melted variables. So let me show you how. So before that, let me clear out my workspace. So mass is like is a library that has the built-in data set. So that's the reason I loaded it first. Yeah. So let's first do the exploratory data analysis. So whenever we do the exploratory data analysis, we first start with the ship's dataset. So this is another inbuilt dataset like empty cars dataset that we have seen quite earlier. So this is something like what is the type of ship and what is the year it has been created, and what is the service period, and what are the incidents that are related to that data set. So we can also view the entire ship's data set. So if you see here, it is what is the year that is it has been created, and what is the period that is in service, and here is the service and its particular incidents. Okay, and pretty simple and straightforward. However, if you want your ship types to be categorized based on their type and based on the year that they were made, like usually how will you do is you will create another variable in here saying another column or another data set saying type hyphen year, which is a hyphen 16. So when you do that, it will be what will happen is there will be just another column which is present in here. So that is what is called the melting of your data set. Meaning, so based on two different available columns, you are creating another dimension of your data for your easiness of access. So I hope this is clear. Let me take a pause and see whether do you guys have any questions in here. So any questions so far, or do you want me to explain anything? Because this melting is similar or somewhat quite difficult to understand in the initial stages. So that's the reason I have stopped in here. If there are no questions, then we can go ahead and do this one, like how to do the melting part. So what we are doing is we'll, we'll just check the manual, like what is the syntax and all. So if you okay, I have to install a package. So I'm installing the reshape package because reshape is required for melting and casting. So I used to have it in my work environment, but not here. So that's the reason I installed it right now. So now I can do the reshape, and now we can see the melt. Yeah. So if you see here, this is the syntax of melt. So what is the data set that we want to melt, and what is the ID, what is the variable that you want to create. So in here we wanted to merge the type and year, so that's the reason we have given it. The other options are like variable name is like once you do the melting, what is it going to be, etc. Like this one you can get it from the syntax document. So now if we look at the molten ships data set, it will be better if we look in here. Yep. So what happened here is this ships is the actual data set, meaning this is how your raw data looks like. Type year is what like we wanted to retain or create a separate column so that we can evaluate the other parameters. What is the period, service, and incidence? If you see it in here, right, what we have basically done is we have pivoted the type and year, and for variable there will be period and service and incidence. So period is listed in here, service is listed in here, and incidences listed in here. You understand the concept, right? Like how we are taking this particular ships data set, meaning so this is the raw data. However, we wanted to categorize these ships based on only type and year, because type and year of the ships is pretty important. The period and the service and then the incidents, it is not so important. So what we have done is we have done the type and year as a pivot columns, and the variable, what are this variable and value are auto generated as in uh, for this, whatever the entry that is present in here, it will be molded to your particular data set. So that if I say a and 60, there will be a period of 60, and let me filter that one for you. Now I'm filtering out the ships type of A, and the year type as 60. Yeah, if you see in here, for type A, which are type A ships which are manufactured in the year 60, we have three different values, which is period, service, and incidents. The incident count is 0, meaning that that's a quality ship, is an inference that we can make. But however, uh, yeah, A 60, and instead of this column period and 75, it is integrated into a variable and a value, period 75. Similarly, the service is 63, the service is 63, so the period 60, the service is 63, and the incidence is 0. If you see here, 60, 63, and 0. So these are these are available in different columns. However, we have molded the data so that it is available in two different columns. Okay. So the reason we are doing is our pivotal columns are only type and year. We are concentrating on it, and not on the other data columns or data types. So that's the reason. So once we mold the data, we can cast this data into a different level. So that one I will show you. So for now, if you have any questions regarding anything, like we can discuss now. So far, I hope you get the idea of what is here. So we'll go ahead to cast the data because there is not much time left. Because by 12 o'clock we'll start with the visualization part, so that you'll get to know like how to create charts and all. So if we go to the casting part, like I think it will be better. Yeah. So once we have melted the data, we have to cast the particular data. So again, this is how you cast the data. So cast the data as in here, like where is the actual data set? Yeah. So let me sort it by year for the better understanding. Okay. So we'll go from the start once again to understand how this casting and melting works. So this for ship type A, which is manufactured in the year 60, we have two different values. Meaning, so this might be duplicated, or we may want to see the ship type by the year manufactured. So that's the reason we molded the data. So this is the actual data, and we molded the data into like this. However, if we see here, it is kind of a duplication sort of thing. A60 period is again a duplicate. How do you want to interpret the data is based on how you're casting your data. So if you go to the casted here, so the melted data set, whatever the molten data set is taken, and we are casting it into the two types, or what are our pivot variables. The type and year is our pivot variable, and what are we going to do? We are going to do the sum of all those variables. Meaning, okay, so meaning when I say A of 60 and 60, we are going to sum these two periods, sum the services and sum the incidents. So finally, what will happen is we will get to see the ship manufactured by years, like be it two ships or 200 ships. We get the ships manufactured by year, by type, and their cumulative parameters. Cumulative parameters can be sum, average, mode, etc., etc. So I hope like sum is a simple sum, average is like a plus b divided by 2, and mode is like what is the frequently occurring incident or service sort of thing. So in here, for our context, we are trying to you know uh, concentrate on the incidents. So what will happen is the recasted ship will have only unique values for type and year. So the ship's dataset will have, say, 40 rows. The recasted ship dataset will have some 20 rows, because for each year and type, we used to have two different rows. So what we did is we combined everything together so that we can cumulatively see the number of incidents that are happening. Because when we see the ship manufactured at year 65, it will have the 111 incidents. But when you see the data set in here, which is ship's data set, it will not be readily visible to you. So when you take average as is, without grouping or molding and casting the data, you'll just say, okay, only 50 incidents happen, so it's not a big deal. But when you group the data, when you start to make sense of the data, the ship count, the instant count for that particular ship type and the year, make of the year, it is very huge, that it almost outperforms the every other ship type. So if you see here, or better we can start, I mean sort, if you see here, this 111 is pretty important, that needs something to be looked at. But if you see in the rudimentary or basic data set as is, you will not get these kind of inferences. So that's the reason you take certain variables A and B. In our case, it is ship type, and in the year it was made, so that you get to the inference of the data and present it to your stakeholders. So I take a pause in here. Hopefully you guys understand the concept, or if you have any questions, like we can discuss it now. So this is pretty important, though it may look a little complicated. If you go through this document, then you should be able to, get a hang of it. I think no doubts or clarifications at this point. So yes, we have completed before 12. We'll just go through the, you know, uh, the final graphs and other visualizations, so that it will be a complete package for you. So we'll go through the index once again. So data types, operators, loops, and then strings, everything is covered. I think it is covered as an, you get an idea of like how it is being used in here. So this CSV files is reading a CSV file into your data frame, which we will look into it shortly. And these databases and all, like once you have it in your system, like you can do it by yourself, because MySQL and Oracle SQL or something that is used in, so in every corporate environment, and you can pretty much use them as well. So we'll just load a Excel or CSV file, and then we'll straight ahead come ahead to this pie chart. Okay. Okay, so what I'm doing is, so I have a CSV file in here. So far I have been telling, when an external data comes into your workspace, how you will be reading it. So this is the CSV file. Typically it will be CSV file because it is easier to transport and handle. So how you can read them is read.csv of the data.csv. So it is simple. So again, as I said earlier, it is not like an fread, or I don't remember like how we can read a file in other programming languages, but it's like a human language. Like you are going to read a CSV, so it is read.csv, and it will be assigned into your x1 variable. So if you print an x1, it will show some employee data set. So it's a pretty simple data set. However, we'll quickly see the parameters which are present. So it'll be better. Yeah. So these are the different parameters that are available in reading a CSV file. Say what is the file. So right now I do not have a complicated data set. So I have just given the file name, and header is equal to false. So header is equal to false, as in the data set does not have the header. Yeah. But in our case we had the header, so it read it already. And the separator is null. So in our case the separator is comma. So that is why it's called a comma separated file, CSV file. And the code, decimal points, numerals, row names and column names are these are standard set of data. So once you start to handle the complex data sets, you can tweak these parameters to properly read your data set into your work environment. So that is the idea. So that is a read table. Table is read table is something. Table, CSV2, a delimiter, everything is more or less into the same wrapper network. So that is a reader class. So the reader class, based on what we mentioned, the table or CSV or CSV2, it will differ from time to time. So that's the idea behind this read.csv. So not necessarily the inbuilt datasets, the ships dataset that we have seen and the empty cars dataset that we have seen. It is you can create your own dataset and bring the dataset to the workspace and you can start working on it. So we can go into visualization now, which is pretty cool. So I haven't created a file, guys, because I do not want to, mess up the whole thing. So that's the reason I'm copying it from a PDF file, which I'm referring to. So far we have seen the data manipulation stuff and reading and the data manipulation as in reshaping the data, melting and casting and etc etc. So right now what we are going to do is so far we have seen the data analysis part. Right now, what we can do is once we do the analysis, how we are going to serve your data is pretty important as well. Meaning, so it is not, if we take a real life example, cooking is important, but equally important is how you serve a particular cooking or a dish. So you should know the visualization tools and graphs so that it'll come handy for you, like whenever it is required. So I did not save the file. Like how to save a file is a different concept, but that's a different story. So meaning you can view the visualization first and then save the file into your ecosystem so that it is later it is used or exported into a different file. So whenever I say pie chart, it has to be in the it has to be like this. Like for each city, we are assigning some values 21, 62, 10, and 53. So not necessarily up to 100%. So usually we take 100% and split it into etc etc. But now the total length of the pie or total size of the pie is 21 plus 62 plus 10 plus 53. So the total size of the pie is 146 and we are splitting it based on the x values. So it is similar to how you draw an x and y chart. So based on the x values, you plot the y. And similarly, we have the x values. And if you just give like pi of x, it will just give you the values like 1, 2, 3, and 4. So but at this level you may not know what does this 1, 2, 3, and 4 stands for. So that's the reason you label them to some extent. So you label them as cities, as marks, as your performance indicators, as your values, anything. So it is pretty important to have labels because with this chart you cannot make any conclusions or you cannot make any inferences. So that's the reason you label them and then you plot the chart. So if you plot now, it will make sense. So based on the city, it is the values are plotted in a particular given pie chart. So similar to pie charts, we have so these are different customizations that you can do it in pie chart. So you can save it in a file or you can say you can differ the colors like here. So color, even you can give the color as red, green, blue, and white. So let me show you that. You see, so instead of instead of giving a regular red, blue, green, and white, what they have done is they have chosen the first few colors of a rainbow. So rainbow, as we know, like all those colors. So those colors are assigned in correspondence with this particular X. So the reason behind making this one, making this dynamic of the pie chart is, say I want to add the Paris temperature. So right now where I'm in, so I'm just including it in the data, and I don't have to add in think of any other color. So if I just execute it, the next color that is in line will be taken over. So let's assume we have another city. We have Berlin. Okay, that's a temperature, which is a 25, and we say Berlin. Now what we are doing is we are just adding the data to the existing data, and we are not making any changes to the plotting of the data. So the plotting of the data which is present as is. So now if you see here, the colors are changed, yes, but the change is dynamic. So you don't have to choose a color every time. So similarly, you can use any RGB color coding. So I hope you are aware of RGB color codings. Similarly, you can write a function for RGB color coding, and you can use endless number of colors for your pie chart, or even for your bar or any other charts. So uh, to do this in a, say again, I'm drawing a parallel between the languages that you learn currently or that you already know with this R language, and I'm comparing them with the R programming language that we are currently doing. So why I'm emphasizing that is, those languages might not be as dynamic as this particular language, is what I'm trying to say. Python is already there, but for Python you have to write so many codes, and you have to, there are so many spacings. So let's assume if this is one spaced out in Python, it will not work because there will be always some syntax error, etc. But now if you see here, even if I do the spacing, or even if I exclude in this much of space, it will not it will still compute, and it will still compile and provide you the result. So it is again for easiness of your easiness to code and easiness to adapt. So that is the reason I have shown this particular example. So now we can go to the other pie charts, like other charts actually, because yeah, there is the 3D pie chart as well, which will show something like this. I don't know but whether I have given the, I think so. Okay, we'll try the plot tricks and then we'll go for the other chart. So the reason I'm showing the plot tricks is this pi is a built-in command, meaning you don't need any packages for this built-in pi command. However, when you do for plot tricks, so where it is, so here is the plot tricks. So with this plot tricks, your aesthetics will improve further. Okay, just making. Your aesthetics will improve further, and you can do some more customization, like your chart title, or say it's a 3D chart, and instead of a 2D chart which looks like a school kid's drawing, it looks more professional and more eye-catchy sort of thing. So this Pi 3D is something like a third-party package, so which is available in the Plotrix library. So similarly, for every use case, I'm pretty sure there is some library which is already present in your R environment. Okay, so that's the thing. So it's just that you have to find out what is the package name and install it and use it with the proper syntax. So that's the reason I wanted to show you this plot tricks as well. So now we'll go to the bar charts. Again, the bar charts are pretty simple. Yep, we are about to have like some 15 or 20 minutes. So just copy paste the data. So if you just give the bar plot, then you'll have this particular, again, this bar plot will pop up. And similar to Pi, the bar plot is a built-in visualization package, and you don't need any sort of specialized packages to do so. But still, it will be your rudimentary graph. You will not be able to label them as label in the chart area. So rather than doing it in Excel, you are doing it in R. And if you want to advance these things, you can do them as well. So like how we did it in here. So here I'm going to show you another chart.
हम अब्दुल कलाम के बदले
Yep. So okay, let me go back to the empty cars dataset so that we'll get to know like how this chart works. So you see here, right? So based on the displacement, so displacement as in, if you ask your mechanical friends, displacement as in like for every second how much the car is being displaced. So it's a sort of metric that helps you to understand the performance of your car. So the more the displacement, the faster the car is. So that is how your the interpretation should be. So again, I'm giving you a quick intro about this empty cars dataset so that we can make some inference from this scatter plot. So scatter plot is something like you have some x and y variable, and just like how you do it in your graphs, you just plot a point and then you create a analysis or inference out of those scatter plots. So let me tell you that. So to give you a quick reminder of like what is this particular data set is about, it is about the cars, which is given the miles per gallon, the number of cylinder, the displacement, the horsepower. Okay, so now what we are doing in this particular exercise is we are plotting it with a third party plotting package, which is ggplot. So this is one of the names that you will hear often if you are doing visualization in ggplot. Okay, so we are doing the data, we are taking the data as empty cars, and AAS stands for aesthetics. So in aesthetics, we are giving the X as HP. So here your x-axis is the number of horsepowers that the car has. Okay, and the y-axis is miles per gallon. The miles per gallon is what is the mileage of that particular car. Okay, and we are adding the one more variable. So it is not like your typical two-dimensional chart. So it's like a three-dimensional chart, which is your color. So in colors you have given the displacement. So where is the data set? Let me close the unwanted ones. So in colors you have given the displacement, like per second what is the displacement that is happening in here. So now if someone so typically how we perform is they will give the data to us, and then they'll ask us to design a model for us to to predict or to assign or to assume using the other data science model. So the data science modeling concept is like somewhat pretty advanced. So I'll tell you the first step towards it. So once the data is in your hands, you need to start uh, making the inferences. It is pretty obvious for us. Say for example, in our Indian car markets, you have cars ranging from the Maruti to Mercedes Benz and Lamborghini and Ferrari, etc., etc. So we also know that the mileage for the higher end cars, say Benz or Ferrari or Lamborghini, is very lower. But how would you present it to your stakeholder or your client or anyone who is interested in the cars? So this is how you can do it. So first you collect the data, everything together, and say that the horsepower. So the horsepower ranges from 0 to 400 or something. Similarly for miles per gallon. So miles per gallon is named, can be translated into mileage. So the less horsepower you have, which is the less powerful your engine is, the more mileage that you're going to have. So for example, some cars, so I haven't labeled them yet because labeling is another concept. So but here, just for our understanding purposes, some cars here, okay, so some cars which have the lower horsepower, say Maruti 800 or Maruti Alto, so those cars have like less than like, say, I don't know, 100 bhp or something. So those cars will have the higher miles per gallon, as in uh, the mileage. So those cars will give you the higher mileage. But as you increase your horsepower to hundreds, like say in hundreds, almost all cars are giving like 20 miles per gallon. Miles per gallon, as in, so gallon is an Western nomination. So instead of gallon, you can say liter. So 20 miles per liter. So the more, the less your horsepower is, the more miles you get per your 1 liter of your petrol. Meaning, so in here, the 1 mile per gallon. Okay, 35 miles per gallon. As you proceed together, as in your horsepower increases now. So in here, if you see, your HP power increases to 200. So when I say 200, these are like basic incoming cars, like a basic model cars, say Maruti 800 or Maruti Alto, etc., etc. And when you increase your horsepower, this is where your medium segment cars come in. Say your SUVs as in Seltos or Brezza, or those medium level cars will have somewhat higher horsepower than the entry level cars. So in that case, your miles per gallon drastically gets reduced to uh, between 50 and 20. It is a known fact that any bigger SUV, say Toyota, we cannot expect the same level of mileage between the Swift and the Toyota, because they're uh, Toyota cars, because they have the greater capacity, they have the greater horsepower, they need to pull more weight, and they'll have like a wider body, etc., so on and so forth. But the idea is, the smaller the horsepower, the greater the miles per gallon. And as you increase in your horsepower, you will get your miles per gallon reducing. Why it is reducing? Why is reducing is the next question that might come into anyone's mind. That is where your displacement comes into the picture. So the displacement, as in, if you see clearly, these are dark bluer dots. So the dark bluer dots, as in their acceleration. Say if you're a car enthusiast, then you'll know that every car will have certain time to reach from 100 kilometers per hour to 0 kilometers per hour to 100 kilometers per hour. Meaning how fast they are moving ahead. So that is what is mentioned in the displacement color coding. So these cars will be slower. These cars, which is between 100 and 200 horsepower, is the somewhat medium level cars, and your high end sports cars will have even higher displacement because they are designed for that purpose. So because of that particular displacement reason, they are giving the low miles per gallon. So this is how you interpret the data and you present the data to your stakeholders. So this is a lengthy discussion. So that's the reason I chose this data set and I chose this particular graphical example, to present to someone, who is not very aware of what is going on. So this is how you present, meaning you take an x-axis, y-axis, and if you want a third variable, and you make a case study out of it. To support my thesis or to support my arguments, I am using this particular visualization. So in the same graph or in the same environment, I have done the coding, I have done the analysis, I have done all those pre-processings, and I have presented them to my stakeholders as well. So it's more like everything comes in the same package. So that's the reason the R is very important for you folks. Think we are about to have time. Yes, we have 5 minutes time. So I think we can conclude the session in here. So if you have any questions or any clarifications, we can talk now. Again, I'm going to give my contact number and my LinkedIn profile, just in case if you want to connect with me over LinkedIn. So here is my LinkedIn profile, and here is my mobile number. So I'll be available over WhatsApp and LinkedIn. So you can reach out to me anytime you want. So for any kind of clarifications or any kind of doubts or any career advices or any sort of help, like, you can reach out to me and I'll be happy to help. And I want to take a moment again and thank you, Mainavati ma'am and Logeshwaran sir, to organize this session, because it's been happy to meet you all and happy to introduce my learnings and how to structurally think and solve a business problem. Thank you, everyone. Thank you, ma'am. So any questions or comments, anyone? So if you have any questions, you can post it in the chat window, or you can unmute yourself and then talk, because we still have, like, say, 5 minutes of time. Yes, exactly 5 minutes of time.
டிபார்ட்மெண்ட்
நான் முடிக்க வரேன், முடிச்சுக்கப்புறம் வாட்ஸ்அப் தேங்க்ஸ். அதில் ஆன் பண்ணி பேசிட்டியா? ம், இரு மெசேஜ் போடுவேன்.
மெசேஜ் பண்ணிருக்கேன்.
மெசேஜ் அவர் சொல்லுவார் எனக்கு, நான் அதுக்கப்புறம் நான் வாட்ஸ்அப் அவர் முடிச்சாருன்னா சொல்லு, பேசி முடிச்சாருன்னா சொல்லு. முடிச்சிட்டாரா? சரி, மைக் ஆன் பண்ணி வாட்ஸ்அப் போட்டிங்களா? கொஸ்டின் சார்ஜ் கேட்குறீங்களா? ஓவா.
Good afternoon, everyone. Today, I feel incredibly honored and privileged to have been allowed to extend a vote of thanks. Priorly, I wish to extend my warm regards to our chief guest, Mr. R. Ilavendan sir, data scientist, PayPal, Chennai. Dr. M. Jayaraman sir, thank you for inspiring us to achieve our dreams every single day. I sincerely thank our respected correspondent, Thiru S.D. Chandrasekhar sir. We are really grateful to have such an eminent personality to lead us. I thank our respected Dean, Professor P. Jayachandra sir, for molding us. I also want to thank our professor and head, Dr. V.K. Manavalasundram sir, and all faculty members of our department. You have fostered a sense of support and appreciation that allows us as educators to improve our practice daily. Finally, I want to thank the student participants of this value-added course. Thank you.